Okay, so in this session, I'll be talking about building a compelling search experience with Azure Search. So my name is Sandrino. It's actually with a capital D. On your previous slide, it was with a lower D. Then it was Eve. Okay, so no problem. I'm an Azure consultant at RealDolmen. I tweet sometimes, I blog from time to time. I also write for justazure.com, like Mike here. And so before we start digging into the technical details, just take a quick look at where we're coming from in the Microsoft ecosystem. And so a long time ago, we had Bing, well, it's still there, but this is where some of the things started in the Microsoft ecosystem. And so Bing, there's Bing the search engine, and there's also the Bing API. And from a marketing perspective, it was the new search product from Microsoft. But actually, the only thing it allowed you to do is to index content of your site and just display it or reuse it. So it could do search, but not in the context of data in your application. And it was simply crawling the pages of your website. So besides Bing, there's SharePoint, of course, products for every customer's needs. And one of the components of SharePoint is a fast search server. And this is a search platform built on top and built for SharePoint. So could be useful in a few scenarios, but not typically for the things we'll want to use and build search for. And then Microsoft started out with the Azure platform. And initially, Azure was platform as a service only, which means that we had our web and worker roles, but without persistent storage. So if you wanted to go and use, for example, Lucene in the cloud, well, you had an issue because Lucene, good evening, hello, please join us. So Lucene uses a file in which it will store its index. So deploying this on web and worker roles without persistent local storage was a challenge. And of course, one does not simply put Lucene.net on Azure. And so people from the community started building directories for or aimed at the Azure platform. And so there's a popular package on NuGet, the Lucene blob directory or the blob store, which allows you to put your index in blob storage. And this was one of the first steps of having a search solution in the Azure platform. And so after that, we got virtual machines with persistent storage, and this enabled us to deploy Apache Solr, for example, in an Azure virtual machine. But then again, you had one instance, and starting to scale out that instance, make it high available, partition the data over multiple virtual machines, was also a challenge to effectively do it and keep that system running. So Solr is a pretty old product, which has been around for quite some time. And so a few years ago, there was a revolution in search with Elasticsearch. And so Elasticsearch was really built for the cloud, built as a high available, scalable search infrastructure. And so actually, this is the best search product available today. So, and after that, Microsoft introduced Azure Search. And for once, they didn't try to build something themselves, which would be just a subset of features of the competing products. No, what they actually did is they built Elasticsearch as a service. So Azure Search is based on Elasticsearch, It's an API built on top of Elasticsearch. And the main idea is that the Azure team, the search team, can make use of all the features available in Elasticsearch, and where need be, that they can extend it with custom features that are not supported by Elasticsearch. And this is why Azure Search does not expose a native Elasticsearch API, but it exposes its own custom API, which interacts with Elasticsearch. And so just a quick overview of a few features available in Azure Search. Well, we have the standard querying features, like on google.com, for example, searching for words, doing wildcard search, sorting our data. As you can see here, on google.com, I can sort by date, filtering my data, maybe on an extension or on a specific site. So these are the basic functionalities available in Azure Search. We also have Faceted Search, allowing us to, I think this is autozone.com, allowing us to build a more advanced search experience, like what we can see here. I'm looking for a car, and actually I can see that there are a few 100,000 Audis. I could click on Audi, get a set of those results, and then keep drilling down on those results. So this is also one of the supported features. We also have hit highlighting, which means that this has been taken from the MSDN forum. If I look for the word Azure, you'll see that the results, or where the keyword was hit, you'll see a visual some visual markup shows where search engine found the keyword. We have Geo Spatial search, allowing us to find results close to a location or inside a polygon, for example. Suggestions, allowing us to do autocomplete. Multi-language, of course. And we'll later in the session we'll take a closer look at what this effectively means for your data. And we can tune our index. So we have full control about how the data or how the score applied to your data is calculated. So you can effectively give specific sets of data a higher priority in your search results. So let's take a high-level look at the concepts of Azure Search. So when you go to the new portal, you can deploy an Azure Search service. And in this example, I deployed a search service called Resto. And the service itself cannot contain any data. So the first step you'll need to take is create an index in that search service. And this could be my restaurants or restaurants production, restaurants test, acceptance, whatever. Once you created your index, you can start creating fields, like maybe the name of a restaurant, the description, the rating, the location. You can send scoring profiles to the index, and scoring profiles are what allow you to tune your data and the results of your search queries. And once everything has been set up, you're able to commit documents to your index and populate the index. And in terms of scalability, once you deployed the search service, you're able to scale it out using replicas and partitions. So a replica allows you to increase the performance of a search service. So if you need more PPS, which would be a query per second, you would start scaling out by adding replicas to your search service. And on the other hand, we also have partitions, and partitions are those things that will contain your data. So if you have that many users, but you have tons of data, well, you'll be typically adding more partitions than you'll be adding replicas. And so this is a very confusing table and not that easy to explain, but let's assume a scale or a unit. So your search service can be scaled out by adding additional units. And a unit, let's say that a unit is a motorbike, and or a Porsche. And so in a Porsche, you can there can be driver and passenger. So you can only fit 2 people in it. So if you're driving alone, well, you still need your Porsche. If you okay, it's a very bad example, but so let's just say that a unit, it can hold 2 things: a partition and or a replica. So let's say that I need a replica. Well, in that case, I'll need to deploy 1 additional unit. But if I need 2 replicas, well, I'll need 2 units. And so unit can hold and partition, but if you only fill it with a replica, well, the complete unit will be used. You'll be able to add an additional partition to the unit, but let's say I need 3 partitions. Well, in that case, I'll at least need 3 units. And if I want to increase this to 2 replicas, well, in that case, okay. I think it's even more confusing, but indeed, you'll need 6 search units. So the important part of units is that it's a slot. Well, it's something that has 2 slots, one that fits a replica and one that fits a partition. And if you don't completely fill it, well, then you're losing half, or you're not using half of that unit. Well, let's say that it's 1 VM, and you can use that VM to increase the throughput of your search service, and to add more storage in your search service. So, very good question. Thank you. Now, in terms of SKUs, we have the free one, which allows us to create up to 3 indexes and up to 10,000 documents. And this is mainly interesting if you're doing unit testing. So maybe I have a web job which takes some data from SQL, brings it over to search, and I want to do some integration testing if my code is working correctly. Well, this is why you'll typically be using the free SKU. In terms of production use, you'll quickly need to move to a dedicated one, which can hold up to 50 indexes and which can have multiple partitions, so 12 partitions, 6 replicas, and 36 units. And so in terms of pricing, I think today it's 250 euros. Well, when it goes GA, it will be 250 euros per unit. So it can get very expensive very fast. And so at the moment, you actually need at least 3 replicas to be high available. And the team is working on lowering this to 2 replicas by the time the service goes GA. So a little more detail about querying Azure Search. So I can enter the text I'm looking for. So Italian restaurant, for example. I can select which fields I'll be looking in. So, or searching in. So maybe, well, in my example, I have a restaurant database. And if I simply want to look for a keyword in the title of that index, the title fields, I can use the search fields option to just look in that specific field. I can use a skip and top for paging purposes. I'm able to get the total number of hits that match my query. So let's say I'm looking for Italian restaurant again, and I have 10,000 hits, but I'll typically only show 20 results. Well, in that case, if I'm building a small paging control, I'll need to know the total number of results, and this is why I'll be able to use the count field in my query. I'll be able to do a order by, and this is very useful from the Azure perspective, because table storage is very limited in terms of what it can do for sorting data. Document DB also cannot sort, so a good way to sort, or if you have a good requirement to be able to sort your data in Azure, besides running SQL database or SQL VM, this is something you could do with Azure Search. You're also able to select the fields you want to display. So in a desktop application, a full browser, web browser application, you'll maybe show a lot of data in the search results. In the mobile application, you'll only show a subset of those fields while using the OData select statement. You can, from a client side, choose which fields you want to return in the search results. We will be able to do some faceting to build the AutoZone-like search experience. We'll be able to do some filtering, and this would allow us to filter results where the rating of a restaurant is greater than 5, for example. Be able to enable highlighting and choose a scoring profile. So here are a few examples of filtering. So on number fields, I can do greater or equal, lower than, so the standard operations. I can do filtering on booleans, and this is also an interesting one. So Azure Search also supports storing collections in your index. So let's take the example of a restaurant again. For a restaurant, you want to know the accommodations. Do they have Wi-Fi? Do they have a kids corner? Do they have parking, a toilet, whatever? So, and if you want to search those collections, the syntax is a bit weird, but this would allow you to do specific filtering on the collections in your index. So a new feature that was added, I think, a month and a half ago is multi-language support. So with Azure Search, you're now able to specify the language of each field in your index. So my restaurant example again, I have a restaurant web application. I'm able to specify restaurants in Dutch, in English, in French, and the restaurant can have multiple descriptions, one in each language. And so by specifying the language of the field and storing data in, Azure Search can do some advanced processing on that data. So it can do stemming, allowing us to turn run, running, ran, runner, all in the same word. And then it won't matter if someone is looking for run or running. It will make sure we hit on all the variations of those words. And also, depending on the language or the analyzer you assign to a field, you will also be able to, or Azure Search will also be able to filter out stop words. So if I mark a field as with the English analyzer, well, it will filter out the English stop words, but it can also be useful then to filter out the Dutch or the French or stop words in any other language. The Geo Spatial search allows us to build a few advanced search features, like searching for data within a specific range. So the end of session, I'll show a small application I've built to find restaurants. And we'll take a look at how easy it is to find restaurants around this location. So in a range of 20 kilometers, for example. You can also use the Geo Spatial support to sort the results of your data, of your query. So, for example, I'm looking for an Italian restaurant. It doesn't matter where it is, but I want the restaurants close to my location on top of the search results. And finally, you can search within a polygon. So this would allow you, just like on Google Maps, to define an area using coordinates and to find data within that area. So if you're looking for a restaurant in Brussels, we'd be able to, well, in code, make a, let's say, a polygon of Brussels to find all the restaurants within that region. So scoring profiles allow us to tune the score of a document. And when you're searching for a document, every result will get a score. And the results with the highest score will be ranked first. So scoring profiles allow us to boost the score of our documents. So again, if I'm looking for Italian, and I have a hit on the name of the restaurant, well, in that case, I might want to boost those results higher up in the search results. And these are scenarios I can implement using scoring profiles. And so you can boost the weight of specific fields, or you can use functions to do some advanced boostings. So functions can, for example, be used. The freshness one, for example, would allow you to give a higher score to documents that are more recent. Distance would then be able to give a higher score to documents close to location. And so in terms of security, when you deploy a search service, you'll get 2 admin keys, similar to what we'll see in a traditional storage account. And besides that, you also get up to 50 query keys. And these are typically the keys that you'll use in your client applications when they need a direct access to the search service. So you have 2 options when you interact with Azure Search. Your client application could go to your backend, and your backend could do the search, or your client can go directly to the search service. And in that case, you wouldn't want to expose the admin keys, of course, but you'll be using query keys and embed those eventually in your client application. In terms of tooling, the new Azure portal allows you to, it's actually a basic management tool of Azure Search. So you can use it to create a service, of course. Recently, the team added support to create indexes. And in an index, you'll be able to create fields. The downside of using the portal is that it's not in line with the latest version of the API, which means that all the multi-language support cannot be used here. So you would need a different tool to be able to add multi-language support, or you'd be needing to write some code or directly interact with the REST API. But so the management portal does not support all features of Azure Search. And to go back to my previous slide, if a client application, if it's a web application, it's typically hosted, well, on your hostname, mywebsite.cloudapp.net, whatever. And let's say that this is an AngularJS application. And so from the client side, you'll be querying the search service. Now, in that case, you're doing a cross-origin request. So we need to be able to set up cores in our search service and this is actually also not supported in the portal. So the portal is the basic management tool to interact with Azure Search. And then of course, you have the REST API, which allows you to do anything that's possible. And so together with my colleague Tone, we built a small NuGet package, RealDolmen Search, because for a little over a year now, we've been working with Azure Search, and we've taken all that experience together with the Azure team, and we created the first .NET SDK to interact with Azure Search, and today it's, I think, one of the only two available community-supported SDKs. So at the moment, there is no official SDK from Microsoft yet. So if you're using .NET, this is actually your the best way to interact with Azure Search. Besides that, there's also a JavaScript client, which you'll be able to use in your Node.js applications or straight from within the browser. The only downside of this client is that it can only have basic interactions with the search results. So you can use it to get the search results, but not the metadata around those search results. For example, how many results did Azure Search find? You're not able to get it with this client. Faceting, like when I need to show some advanced filtering on the left, is something I cannot reach into with this client. So in terms of maturity, the JavaScript client is not really in line with the features available today. And then there's another fantastic product, which we've also built. This is the RealDolmen Search portal. And this is, let's say, this was the first visual tool which had support for Azure Search. And there's another commercial tool, CloudPortal, which actually copied a lot of these concepts and put them in a commercial product. And this is actually, this visual tool is in line with the latest API. So let's see if I can show it here. But here, for example, I have two fields on which I've specified the analyzers, which I'll need to be able to have the multi-language support on my fields. And using, sorry, using this tool, you can specify your course settings, you can specify scoring profiles, you can import data. So if you have a CSV file, you can simply import that data in your index without having to write one line of code. You can use it to search for data. So it's, I think today it's even if we made it, I think today it's the best UI to manage Azure Search. And so what we did to make the experience a little bit nicer is we actually built, we packaged it as a site extension. So if you're using Azure websites today, you can simply go to the new portal and add it as a site extension to your Azure website. So you won't need to write one line of code. There's no need to deploy anything. You can just add it to your website and then simply open it up from the portal. Okay, so let me just show you what I'm talking about. Can you read it in the back? Okay, what will we do? Let me just change the resolution. Is it going to break Google Hangouts? Zoom? Okay, old school. So let's say I have a website here, Resto Square Legacy. If I scroll down a little, there's the extension options, and this is where I'll be able to add an extension. And one of the extensions available here is the Red Dog Search portal. Okay. So, okay. And that's it. So now the extension has been installed on my website. And it should be showing up any second now. Is the internet slow, or is it just the portal? Okay, there it is. And of course, it won't work immediately because it needs the credentials to your search service. So you'll need to add two keys, the Azure Search service name and the API key. So let me quickly add those to the settings of my website. And the API key. And this is the name of my service. And the API key. What? No, no space. Okay, and there's still something a little bit wrong with how extensions work. So I might need to restart my site a few times for the settings to be applied. Yes, but now it looks like after one restart, it works. And so this is where I'll be able to have a look at my indexes. I'll be able to create new indexes. And so here's an example of an index I built for this session. This is my restaurant database, which is the source of a small application I built. And this is where I'll be able to add additional fields to my index, set up all possible settings for those fields. And recently, we also added the, I'll need to add a new one for that. We also added support for all the analyzers. So if you need some French data in your index, you can mark that data as being French. And this will make sure that the stemming and the stop word cleaning is applied to that data. So this is where I'm able to manage my complete index. And once I've created this index, I can set up the course settings. And this is where I'll need to have the URLs of my single page applications, my JavaScript web applications that need direct access to my search index. So something useful here is being able to search your index without having to build something yourself. So you imported data, you added some scoring profiles, and you just want to test how your data is showing up after tuning the index a little bit. Well, you can simply start here, and this is where I'll have an overview of all the restaurants. So I have the Bertembrug in Bertem, and this is a good place to start and have a first interaction with querying your data. So, for example, I'm building a mobile application for this data, and I want to limit the number of fields that will be returning. So in that case, I could filter on name, postal code, and street, for example. And you can immediately start testing this. Now, typically, if you're building a single page application, you'll be writing it in JavaScript, and you won't have the .NET SDK. but you still want to have some insights of how it's querying the index and how the URL is built. Well, in that case, let me see if I still have it here. Okay. What you can do is simply get the portal from GitHub and start it locally. Okay. Oh, it doesn't contain any. Okay. Doesn't matter. So if I start the portal locally, let me do this and then do this. Okay, so if you start the portal locally, let me just shut this down. If you start the portal locally and you spin up Fiddler in the meanwhile, you can actually see all the queries that the portal will be doing to Azure Search. And actually, it's not showing. No. Here it is. So you'll be able to see how the query is built. So the native REST call, and you'll be able to simply reuse this in the JavaScript applications you're building, because there you won't have the support of the .NET SDK. So even if you're not planning to build anything in .NET, this could be a good tool to have a sort of a debugging experience when interacting with Azure Search. And of course, you can drop in CSV files and the data. If your CSV has a column which matches the name of a field in your index, it will simply start populating the index with data from your CSV file. Okay, so I think I missed a slide. No, okay, I deleted it. Okay, too bad. Doesn't matter. So, oh, no, this is actually not. I made a politically correct one. This should be okay. Okay, actually, okay, I started with the wrong presentation. Sorry. So this is actually my good slide deck, and so this was the slide I was looking for. So I'm talking a little bit about Azure Search, of course, but actually, well, the main, or in addition to simply talking about the bits and bolts of Azure Search, I also want to share a few of the lessons learned, because we had the chance to work very close to the search team while we built an application for healthcare. And so this database, this healthcare application, they had a database of about 4 million providers, and it was in a SQL database. It was almost impossible to get the data out. And so this was I think, one of the first projects with Azure Search. I think Coded also did something with Azure Search. Okay, doesn't matter. So what I want to say is that after having talked about the technical aspects, I'll also want to share a few of the lessons learned, and it was so much better. Let me just go a little faster. There it is, the politically correct slide. Because at Mobile Dev Day, Scott Hanselman told me, and he was actually right, that it was very offensive towards Entity Framework, my actual slide, this one. So I changed it to this. And this is actually still right. So from the project we did, we had a huge database with many relations, and getting that relational data out of your database is actually not that easy when using an ORM. Well, you can write some code, but it will be a very painful and slow experience. And so this is why we had to find other ways to get our data out. And then you'll need to be thinking about batching your data. You won't be able to do a select star from huge tables, but you'll need to think about getting data out in batches of 500, 1,000 records, process those records, and then go over to the next batch and the next one. And tools like Dapper, for example, or native ADO.NET queries can help you to get the data out in a very fast way compared to a traditional ORM. So when you're using Azure Search, you'll also need to think about population strategies. How am I going to take my traditional data coming from an on-premises dataset, from a SQL database, from wherever, and how am I going to bring this to Azure Search? Because Azure Search today is about population of your index. So you'll be pushing data to Azure Search. And so you'll need to think about when and how many times will I be doing a full index. Will I be working with differential indexes? So at the end of the day, shipping over the data from your database to Azure Search? Or do I want this to be real time? And so for the platform we built, someone was able to sign up as a doctor, as a hospital, and they'll be paying for that. And well, they assume that once they pay it, well, that they're there in the search results. So for that scenario, we needed real time. And if you have implemented something with a messaging infrastructure like CQRS or on top of service bus, well, then it's a lot easier to build a near real-time search experience, because when you're persisting to your SQL database, at the same time, you can persist a flattened version of that data to Azure Search. And each time you're in a process that starts modifying data, if you're using messaging, and this is an asynchronous process, it's okay to also persist a duplicate version of that data in Azure Search. Now, if you don't have a fancy messaging infrastructure, you can simply, if you're using Azure, you can simply fall back to web jobs and have a web job with a queue trigger. And once it receives a message from the queue, you can start filling up your index asynchronously using a web job. Geocoding, this was also a huge challenge because we had a database of 4 million records without coordinates. And the key feature of the platform was find data based on coordinates. So we had to start indexing 4 million records. And if you look at the pricing of the Google Maps API, of the Google Maps API, whatever, it's very expensive. So I think for maybe 10 or 100,000 geocoding requests, you'll be paying maybe 1,000 or 10,000 euros. So having to index 4 million records, it was a complete disaster. So we had to find a few free alternatives like OpenStreetMap and MapQuest. But the challenge there was to overcome the maximum number of requests from a specific IP address for a specific day. So we had to find all sorts of tricks of starting VMs, indexing a little bit, stopping, deallocating the VM, getting a new IP, and all those kinds of tricks to index all our data. So yeah, exactly. So that was a challenge. Now, what we had, the issue we had is that our database contained data without coordinates, but storing coordinates and updating that database with all those 4 million records would also have been a painfully slow experience. So what we did was simply build in table storage an index of street, city, country with the coordinates. So which meant that if we had to do a full reindex of our data, we could simply, before doing some geocoding, look at table storage. If we found a match for that street, that city, that country, we would simply get the coordinates from table storage. And if we didn't have a match, we could do the geocoding. But the cheapest way to do geocoding is by using the browser. So in the browser, you have the Google Maps API, of course. So when a customer signs up and he enters his address, well, you can simply do geocoding in the browser from his IP address and geocode that address to coordinates. In terms of multi-language, you'll be thinking about how am I going to structure my indexes? Will I have one index containing all the restaurants with a field description NL, description FR, description EN, title NL, title EN? So will I be storing everything in one index? Or will I split up my indexes per language? And depending on the requirements, you need to go with well, one of these two, of course. But in our scenario, we had to be able to find everything at once. So we had to store everything in one index, because today Azure Search does not allow you to do cross-index searches. And this is a feature which is available in Elasticsearch, but which has not been exposed by the Azure Search team. So this is a very interesting or very important restriction. So if you would need cross-index searches, you would need to find a way to combine all those indexes in an additional index containing all your data. In terms of deployment, Azure Search is part of your deployment. So if you deploy version 2 of your application, which contains additional data, more data, you only need to make sure that when you deploy that applications, when you would typically do entity framework migrations to update your database, well, you would also need to do something to update your search and index to enrich it with additional fields and potentially even re-index your data. And also something else we looked at is a way to swap indexes. And swap indexes would be similar to the concept we have in cloud services, where you have a production and a staging environment. You update staging to vNext, and then you swap it to turn staging into production. And this is also a pattern you'll need to apply to your indexes. And I think in my example, here it is. I have index prod A, which would be my one slot of my production deployment, and I could think about creating an additional index prod B. And why is that important? Because I could have version 1 of my index, and then afterwards, well, actually, that index, I didn't want it like that. I want to structure the fields in a completely different way. Well, today, that's not possible with your indexes. So once you created a field, you can only delete it. There's no way to update the field. So, and actually, I don't even think you can delete them. No. When you add a field and you save it, there's no way to remove or update the field. So if you make a mistake or if you the requirements change and the structure of your index changes or should be able to change, well, in that case, you're stuck. Your site is live, it's interacting with your index, but it's not right. And if you want to update it, well, you'll need a strategy to provision a secondary index. And once you're done, to swap it over to the main production index. So you'll need to think about a swapping strategy. Okay, and maybe to end this session, I have no clue how many slides I have left. Yes, okay, I have a few. Okay. So what I did is I got my hand on some data, and this data actually comes from a popular restaurant website, and I imported this in a SQL database. So let's say that this is the typical start of your search adventure, is that you have a SQL database filled with data. And you have a good old legacy ASP.NET MVC application which interacts with your SQL database. And that's it, fantastic. And now you finally have the opportunity to build a compelling search experience with Azure Search, and you want to ship that data over to Azure Search. So the first thing you need to do is to have a population strategy. So let me go back to Visual Studio now. I'll be posting this on GitHub. But the first thing we'll look at is some web jobs. Let me zoom in a little bit. Oh. And so part of our indexing strategy is maybe we're doing messaging and we're doing real-time updates of our search index, but potentially we might be missing out on some updates. But so which means that from time to time we want to do a full index. Also, when the structure of our index changes, we might need to do a full re-indexation of our data. So here I built a small client, or a web job, sorry, which gets data from the database using Entity Framework. So this, if we look at the logs, you'll see that this is, I think, 4 times slower than putting the data in Azure Search. And so we're flattening the data. And from an ORM perspective, this is the thing that takes a lot of time. So just building up the relations and getting the data out. So, and once we have the data, we start batching it. And to batch your data in a database, you can simply order by a specific field and then do a skip and a take on that data. So in my web job, I have a simple loop somewhere. Where is it? Okay. Find it again. Okay, here it is. So I skip 0 records and I take 500. So I'm batching in batches of 500. I get the data. So I have my restaurants. And then what I'll do is using the Red Dog Search client, I'll simply create a set of operations. And when you commit data to Azure Search, a batch is limited to 16 megabytes or 1,000 records. So this is why, just to be safe, I'm creating batches of 500 records. And so for all the restaurants, all the flattened restaurants I got from my database, I simply create an index operation and add it to a collection of operations. So this is actually, this represents one document in my index. And then I simply call the populate async method to send those 500 records to Azure Search. I could have some exceptions. So if I'm missing a key, for example, or if I'm committing a field that does not exist, well, this is something that would show up in here. And then I'm moving forward and I'm simply skipping over the 500 next records. Then I'm skipping over 1,000 records, 1,500, etc., until it's done. So let me deploy this. Let's deploy this to our legacy website. And so then we'll start it, and then it will start moving our SQL data to our search index. So let's take a look. Blah, blah, blah. Okay. So my web jobs. Of course. Here it is. So here is our full index job. The good thing is that it's reusing the same keys as the Red Dog search portal. So I can share my search. Oh, I need to add an additional one. But we can share our the credentials of our search service over our website, over the Red Dog search portal, and over our web jobs interacting with Azure Search. So I'll add one last setting, and the index name I think was prod A. Ooh. What is this? Okay, so if I start this web job, we should see some activity. Let's run it and look at the logs. And we'll see that the web job will start getting data from the database if I didn't break anything. Let's wait a little bit for the first results. And I think at the moment what we're experiencing is a slowness of our ORM. Oh, it actually failed without any details. Timeout. Did I forget something? Oh, I think we just got a good old throttling timeout. I'm not using retry policies here in this demo, so let me just try to run it again. But if we get another timeout, just believe me that it works. We'll just look at it one more time. Let me just check if I'm on the right database, QDYD. And QDYD, yeah. No, okay. So the new database tiers aren't all that great. Not found. Okay. Let me just double check one more thing. So, of course. Of course. Okay, so I actually have two search indexes, one in the free tier and one in the standard tier. And since my database is has a size of 13,000 records, I won't be able to use a free tier. So this is why I quickly created a standard one, and I'll need to update the settings of my site in order for my web job to be able to connect to it. dangers of making last-minute changes to a demo. Okay, so let's start this one last time. Do I still have time? 5 minutes? Or was it you have enough time? 5 minutes, okay. So in the meanwhile, okay, here we go. So now it's indexing all my data, and you can just show it. So it took 20 seconds, about 20 seconds to get 500 records from my database. And why? Well, because SQL database is slower than a traditional SQL server, unless you get the premium tier, which I cannot afford. And also getting relational data out of your database is slow. You need to do joins over multiple tables, and this is simply very time consuming. And so putting the data in Azure Search is, let's say, 3 times faster than getting the data out of our SQL database. And here we go. So my search index is now warmed up, and my database is still slow. And now it will take a few minutes, and once that's done, well, our index has been populated with all the data from our SQL database. And now we effectively have a web job we could schedule to run every Sunday evening to make sure that at the start of the week we have a clean index with the most correct data available in our SQL database. So this is one way to populate your data, but the other way is when a customer will sign up for your product, or you'll be adding some restaurants, some hotels, some data you want to index, and you want to index it or be able to search for it right now. So a last thing I'll show is the real-time search. So let's go to this project. And this is a very simple web job. And so legacy MVC application on which I can simply add a new restaurant. Is this working? Okay, so this is slow. Okay, so on this simple MVC side, I want to be able to sign up with a new restaurant. And of course, the restaurant needs to be persisted in persistent storage like my SQL database. But besides that, I also wanted to immediately show up in our search results. So what I did in this MVC application, we're not immediately writing to our SQL database, but we're sending a message to a queue. And on the other side, we have a simple web job, which has a queue trigger on the commands queue, and which will get the request to create restaurant. It will start geocoding it, because my MVC application has no client-side JavaScript, so I didn't bother to do the geocoding on that side. So I'll be doing it in the web job. I'll persist it to the database, and after persisting it to the database, I'll be persisting it to search. Now the advantage of using a queue is that if my search service is down for whatever reason, well, my record will be persisted to the database. And if I have an idempotent process, the next time the message will be processed, I'll check if it already existed in the database. And in that case, it will exist. So I'll skip the database part and simply commit it to search. And so the persist to search method is very similar to the full provisioning one. We still need to flatten the data, but this time we'll only be talking about one record. So let me quickly deploy the real-time one. Let's go back to our web job in the meanwhile. Still indexing. And Azure Search is still at full speed. And so for the final demo, we'll just deploy the web job. We'll should show up in the portal any second now. Here it is. This is our real-time job. So a last thing we'll do is create the Azure restaurant. The cuisine is what? Cloudy. No cloudy. Let's take Corsican. 50 euros. The street is rating 1. Street is whatever. Belgicastraat. In Zaventem. The region is Flemish Brabant. And there we go. And so now on the side of our web job, we should be able to see some activity here. Oh. Here it is. Okay, so we received the Azure restaurant. We did the geocoding in the web job. We persisted it to the database and also to search. So, which means that if we go to the single page application, and if you want to use it or test it, it's restosquare-spa.azurewebsites.net/app. So not the easiest URL, but this is it. And so this is a simple AngularJS application, which interacts immediately with Azure Search. So there's no .NET backend, it's pure JavaScript. And a quick look at how it works. Of course, we have some grunting, but this is actually the only code I had to write to build the search experience we'll be looking at in a second. So this is the, actually I'm wrong. Resto Square. API key is this. Resto Square. And this is prod A. Let me deploy this again. There we go. Because of course we'll want to test if the Azure restaurant is there. And the URL is /app. And let's try Azure. Let's try debug mode. Azure. No, I think I broke something. One last debugging try. Ooh. Is anyone seeing results? It worked, it worked. Live debugging. Here it is. Add requests. No. Okay, let me just wait. This and this. What am I doing? I have no clue. Okay, it's maybe the dash. Okay, whatever. So the of course. Let me just use the portal to show it. We'll do a search for Azure. And here is our Azure restaurant. But the demo effect is gone, of course. So let me just finally show how the application looks like on my free tier. I already set them up, so okay. Here it is. So this is still on my free index, so it won't show the Azure one. Quick look with the debug mode active. If I look for Belgicastraat 17 in Zaventem, you'll see that my browser is doing the geocoding, so I immediately have the coordinates, and I'll be able to spin up Fiddler, and my browser will look for restaurants close to Zaventem. Wait, let me just add Belgium. What is happening? Okay, let's try just Zaventem then. Maybe Fiddler. Let's say that, it's Fiddler, of course, with Firefox. Here it is. Thank you, Maarten. So Belgicastraat 17. We have the coordinates, we search, and as you can see, we'll be finding results close to Zaventem and around Zaventem. And so this is where I'll be able to start using my facets. So this is actually a simple JSON object you get from Azure Search, and which allows me to drill down on the results. So of course, we only want 10-star restaurants. We found 3 matches, and then we want to drill down to Chinatown, and that's it. So we now have a single-page application that can leverage all the advanced features of Azure Search without even requiring a .NET backend. So this would allow you to integrate Azure Search with your Windows 8 applications, with your Xamarin applications, with whatever kind of application you're building. Okay, so and that's it. Any questions? No? Yes?
There's already a huge ecosystem. Plugins, tools, and so on for Elasticsearch. What are the main selling points for Azure Search compared to Elasticsearch?
Yeah, it's offered as a service, so you won't need to set it up in a high available. Yeah. Yeah.
I see the interaction with Azure websites and data that can be indexed.
Very easily, yeah. Yeah. Well, the main selling point is that the Azure team has a different development cycle than the Elasticsearch team. So in the future, you'll see features which I can't share at the moment, but you'll see features that go beyond what Elasticsearch has to offer. So it will be different features than what you typically find in Elasticsearch, mainly focused on Microsoft products and other things in the Microsoft and Azure ecosystem. So, but of course, it's a good argument because Elasticsearch has a great ecosystem. If you run it on virtual machines, it's actually cheaper than using Azure Search. But still, it's the main advantage for our project is that it's offered as a service. So we built a product for a customer, we deployed it to production. The customer now is selling it, and we won't be doing a lot of active development on it. And so from a maintenance perspective, there's no need to do any operations on Azure Search, and it's just one of the PaaS components available out there. So.
Right now we have already a project that's using Elasticsearch. Suppose there's no migration path. Elasticsearch.
No, because the API is totally different. So yeah. Other questions? Yes.
Talking about SharePoint search, is this a faster, cheaper alternative to SharePoint search?
It could be, but again, SharePoint search will do the indexing for you. It will take into account permissions. It will take into account many things. And this is something you would need to implement based on your requirements in Azure Search. Just getting the permissions, your SharePoint permissions in there might be very challenging and maybe not worth the effort of integrating this with SharePoint. I have no clue how SharePoint is doing in terms of performance. I guess very bad, so I'd say yes. Yes, it's better. Yeah. And yes? Not today, no. Because that's also a good feature in Elasticsearch, finding keywords or queries that did not have a hit or not many hits, not supported today. Other questions? No? Yes? Yes, it can take some time before the results show up. So I was lucky to have the Azure restaurant showing up almost immediately, but there can be a delay of a few seconds. But all of that is handled by Azure Search. Other questions? No? Well, then I would thank you for your attention and follow my blog or follow me on Twitter if you want to learn more about Azure Search. Thanks a lot.
We're going to have 5-10 minutes.